Assalamu alaikum. Good afternoon, ladies and gentlemen. First of all, I'd like to apologize for having this presentation in English. But it was just prepared this way. Secondly, I would sincerely would like to thank CACS for having this opportunity to present the work that has been done in the open source community in this successful Sarah event. In this presentation, I'm going to discuss the open source initiative that we have in Saudi Aramco. The main purpose of this presentation is just to convince the audience or to convince people. And yes, open source is not only restricted into labs or R&D work. It's also can be done or can be tailored to multi-billion projects, even national projects مثلا في Aramco السعودية, or international projects worldwide. Before going deep into the open source and what we do with open source in Saudi Aramco, I would like to shed some light on the introduction of our data center, which is the XPEC Computer Center. The word XPEC means exploration and petroleum engineering center, which is shortened as XPEC. So the XPEC Computer Center, it's a worldwide center. It has been listed 5 times in the top500.org, which is the list of the top 500 supercomputers around the world. The combined compute power that we have in the data center is around 512 teraflops, which is number 12 in the world. If you combine the compute power in the data center. So what's the challenge? What do we do in with the open source in the field? First, the challenge is that we want to employ the high performance computing equipment that we have to find effective and efficient solutions tailored to our applications. Our applications are divided into 2 fields: seismic applications, أو عمليات السايزميك في العربي, and petroleum engineering or هندسة البترول. So نعمل على التنقيب وهندسة البترول في الداتا center. So the requirement is we want a cost-effective solution. The solutions are everywhere. We can go anywhere and do our processing, عمليات التنقيب and petroleum engineering. But we wanted to have the cost-effective way because as مثل ما هو معروف أن the largest oil field in the world is in Saudi Arabia. So if you don't have such application that run on your environment, you wouldn't find a better place. Secondly, we want a practical and production use. And thirdly, we wanted to have it as efficient as possible. So in our data center, we have so many computing power. We have our desktops, and Zamili Yamil Khatib, after this presentation, will talk about the desktop initiative. So yes, we employ the open source in the desktop as well. We employ it in the high-performance computing or in the servers, and this is what I'm going to introduce to you. We also do it in the database processing, general purpose, which is not in the high-performance or the desktop computing. So again, before going deep into high-performance computing and what we do in the open source, what's an HPC, the high-performance computer? The high-performance computer is nothing but a bunch of workstations, a collection of workstations connected together in a normal network or high-speed network, and they work together as a supercomputer. So, in practical terms, you have workstations, hundreds of workstations, or even thousands of workstations. In Saudi Aramco, we have around 6,000 workstations connected together to run as a supercomputer and to do our petroleum engineering and seismic operations in this machine. In other terms, and in other view, just for efficiency and production use. So these workstations are stacked or racked together in rack bases in the data center. What are the applications? So we have the seismic acquisitions, أو عمليات السايزميك, عمليات التنقيب, seismic interpretation, remote visualization, and reservoir simulation, اللي هي هندسة المكامن أو محاكاة المكامن. We'll start with the seismic processing. يعني excuse me for that, but then I have to explain to you the business or the process that we go through, just for you to appreciate what we do in the center with the open source, and just to convince you even more. And yes, open source can work for multi-billion projects. So seismic processing, it's like alteration of seismic data to suppress noise, enhance signal, and migrate seismic events. بمعنى آخر, seismic processing is nothing but getting the images from the underground. Think about it like the ultrasound in pregnancy. مثلا إذا رحت مثلا في المستشفى في الحوامل مثلا, إذا كانت واحدة حامل, they do the ultrasound imaging, so you can see what's inside. You can see the infants or the babies. طيب, the seismic processing is exactly the same. We send ultrasound to see the layers of the underground. And then these images are taken to the interpreters so they can decide, yes, there is oil there, or no, don't drill in here and don't do anything in there. And they go around. So what's the process? So we know now the work of the seismic processing. What's the process? The crews or the petroleum engineers, they go into the fields and they do the shootings or the explosions. And then these explosions, they send the ultrasound or even the waves, and these waves they get recorded into the phonemes or the microphones. These are terabytes of data. Yani we are talking about 50 terabytes a day. And this data is stored for all the years, because this is like a national treasure. يعني هذه معلومات يعني كأنها معلومات وطنية. يعني you have to store them for all the years, since the 60s or since the 70s. Every day we get 50 terabytes of data. These data are there, we get them from the field, and then we run them in the open source machines, or open systems and open source machines. In terms of reservoir simulations, after getting these data, we want to visualize these oil wells. We want to see them in 3D. And instead of seeing them in 2D, we can get these data and re-simulate them in 3D. So reservoir simulation is nothing but seeing the oil wells in 3D after getting the data from the fields. So the requirement for reservoir simulation is to visualize them in real-time processing power or compute power. And as you imagine, we need huge compute power to simulate this data. The last thing we do in our data center is remote visualization. In the past, the traditional remote visualization is that you do visualization in your desktop. In our data center, we do it in the high-performance computers. So these high-performance computers, they have this compute power. We do the remote rendering or the remote visualization. We send the rendered images after doing the rendering on the high-performance computers, and we only send images. So these images are very lightweight. They are very, very small in size. And then we can send them, because they are lightweight, we can send them over the network, and you can even display them in your laptop, because all the processing is done on the backside. So far we have talked about the operations and the processing that we do in our data center. So now we see how we employ open source layers in our data center. The high-performance computers, they consist of layers. First layer is the hardware, and for hardware we employ open systems. We are not stuck into, for example, one vendor. We do it in multi-vendors. We can have machines from IBM, from Sun, from SGI, from HP, from any open system that employs, for example, 8086 technology. The operating system, we employ open systems. We employ Red Hat, for example. We used to employ other distributions. So it's up to us. It's our choice to employ the operating system that we want to run. Another layer we employ is the MPI, or the message passing interface, the cluster management, and the job scheduler, which we'll discuss in the next slides. So the operating system, as we discussed, we employ the Linux. And there are several reasons why we employ Linux. We started our data center in the 70s. And in the 70s, we used to use the Cray. And then we moved from the Cray to the supercomputer, and then from the supercomputer to the high-performance computer. So to users, they got used to the Unix, the normal Unix. So moving from Unix to Linux is easy. So that was a plus to them. According to the Top 500 2008 list, 91% of the supercomputers around the world is based on Linux or Unix in general. And only 1% is running Windows. Why Linux? And I think this has been covered in so many presentations, because it's free, Unix standards. Unix standard, that was one of the big pluses that we had in our data center, because as we said, our users, they used to use Unix in the past. So the migration for them was so smooth. Performance, actually that's a third main reason why we had Linux. So many people, they got motivated and so enthusiastic about using the open source just because of the name. Sometimes the pride gets into you saying, okay, let's use open source, even if we don't have the expertise and so on. Actually, that's not, shouldn't be a motivation, a total motivation for you. Because sometimes you'll get lower performance when you do this. If you do, for example, operations in Linux or something. So you have to test it first. And this is what we did. In 2001, we got 2 machines. And we tested both. We tested Unix and we tested Windows. So money, yes, it's a motivation, but it was not the only motivation we had. We had to care about operations at the end of the day. So we tested both. And Linux exceeded the performance by far than Windows, especially for our applications. So that was the third benefit that we had. Support an open community, that was a fourth motivation. In terms of the message passing interface, that's the layer that makes the high-performance computing communicate between these 2 nodes, or between the many nodes that we have in the clustering. And again, it's an open source, so we are not paying anything in that layer. Job schedulers. Job scheduler is basically the interface for the users to submit their jobs, we call them jobs, or to submit their operations in these clusters. So even the interface to the users is done open source. So if you think about it, we have the hardware, we have the operating system, we have the job scheduler, all done open source, free of charge. The fourth thing is for the system administrators, and this is the cluster management tool. For system administrators, you have to manage your clustering, and you have to be effective in managing your cluster. And for that, we employ several packages, for example, ROX or OSCAR, XCAT or CMU. All of these are open source. You can even just go to the internet and grab them and run them on your cluster. The last thing is the monitoring. We are 24/7 monitoring our center, and that's just a snapshot, for example, of what we see. So even monitoring, we are doing it open source. And that's another shot that we have for monitoring. So in this screen, we are just monitoring every node or every machine or every computer in the high-performance clustering we have. Right. So far, we have covered the environment. We have covered the layers. And inshallah, I try to convince you, and yes, all the layers are open source. It's a multi-billion project. It's a multi-billion machine that all the seismic operation, عمليات التنقيب وهندسة البترول in Aramco, في Aramco السعودية, is done free of charge. Other than buying the hardware, all the layer, the software layer, is done just open source. So what was the history? And what were we using in the past before the open source? In 1984 to 2001, we started with the Cray supercomputer. That was a single source. So it was just one vendor to depend on. It's like, think about the cars in the 30s or the 40s. Like Henry Ford, as he said, you may choose anything or any color you want for your car as long as it's black. It's the same thing in here. You can choose any supercomputer as long as it's Cray. So that was the only choice for us that day. And of course, we're not talking about bills, but you can imagine the millions and millions that you have to pay because it's just one vendor. In 2000 to 2005, we got a bit of freedom because we moved to the open systems, which was the IBM supercomputer, but still, it was just from one single source. Starting 2001, and this is where when the high-performance computing or the clustering, Linux clustering started. We did our proof of concept. We got the two machines. We tested Linux and Windows, and we saw the performance. We compared it against IBM's supercomputer, and we saw the benefits in terms of cost, in terms of operations, in terms of everything when moving to Linux. In terms of computing capacity that we have in the center right now, actually you may see it, in 2010 we reached 513 teraflops. And this is comparable to a number between 10 to 12 around the world. And as you may know, KAUST, they have one big machine. They call it Shaheen. And it's in the 20s. So our center combined is number 10 to 12. In terms of storage, we reached 7,000 terabytes of storage. In terms of petabytes, it's 7.2 petabytes of data, of seismic data and petroleum engineering data. And as I said, we don't delete anything. All the data that we got for the seismic, طبقات الأرض, في petroleum engineering, they are all stored since the 60s, 70s, 80s, 90s, and up to this date. What's different this year? Actually, I delivered this presentation last year in another conference. Yes.
ممتع جدا بالمحاضرة لكن الوقت انتهى فحاول تنتهي.
That's the last, should be the last slide. Okay. Computing, we employed grid computing, so we combined all the high-performance computers in our data center to employ grid and cloud computing. So to our users, if they submit, for example, a job, they shouldn't care where the job is running for the seismic interpretation. That's the last slide, I promise you. So over years, while employing grid computing, we got 4 to 10x in performance. We got scalability because it's around the center. Support for large-scale clusters. So even if the area is large, for example, Ghawar or Safaniya or Harab, we can run it because of the large supercomputers that we have right now. طيب. At the end, I would like to thank you and apologize for having more time in my presentation. If you want to contact me for any collaboration, for example, or an opportunity for the high-performance computing, open system, or open source, these are my contacts. Thank you again for listening. شكرا.